All right, so continuing on with section 17.3, biosava. With a single moving charge. So if you recall, the electric field of a point particle is equal to 1 over 4 pi epsilon naught q over r times r hat. And then if you have a moving charge, you have B and E not equal to 0. So magnetic fields are measured in Teslas. And the magnetic field, bad luck, for a single moving charge we have B is equal to mu naught over 4 pi Q V bar times R hat over R squared. Mu naught over 4 pi is a constant. It's equal to 1 times 10 to the minus 7 Tesla meters squared over Coulomb meters per second. Exactly, it is not an approximation. V is the velocity of the point charge. R hat is the unit vector that points from source to observation location. All right, so you'll notice that this formula has a cross product in it. So we're going to do a quick review of cross products. So of course we did this last semester, but perhaps it's been a while. So I'm just going to show some notes on how to do a cross product. So a cross product, if we recall, A cross B, if A and B are in X and Y, then A cross B will be in Z. A cross B is in positive Z, then we write it as a little circle with a dot, and that means the arrow is coming out towards you, so it's coming out of the page, out of the board, out of the book, and it stands for positive Z. If A cross B is a negative Z, you'll see this symbol here. Those are the tail feathers of the arrow. So that means the result is pointing into the board, into the book, into the page, etc. So the formulation for A cross B, you have AYBZ minus AZBY in X, AZBX minus AXBY in Y. Oop, wait a second. AX. Oh, that is supposed to be, sorry, ABZ. And then AXBY minus AYBX. And so you can see here that you have only X and Y making up the Z component. You can also express AX or A cross B as the magnitude of A times the magnitude of B times sine theta of the angle between them. Now this formula can be a bit hard to memorize, and so I often recommend using the IJK method for doing a cross product. So you line it up, IJK, IJ, you go down from I, so you have AYBZ minus AZBY. AZBX minus AXBZ, and then AXBY minus AYBX. So this is actually the method I used for doing cross products for till about halfway through my second year of studying physics, because it's just a good way to keep track of what you're doing. It keeps you from losing as many symbols that you're trying to keep track of. So my personal advice. Now with the right-hand rule, you can use this to determine direction. So if you draw the vectors tail to tail, put your hand with the first vector. So if we do A cross B with this one, we put our right hand on A and we curl towards B. And then the result is going to, in this case, is going to be in positive Z. If we were to flip this, do B cross A, line up with B, cross towards A, this result is in negative Z. Likewise, we have A cross B, negative Z, B cross A for this one, positive Z. All right, so that wraps up 17.3.